The exhaust part of a gas turbine engine on some aircraft has some other functions aside from propelling the jet gases or the exhaust gases rearwards. On some aircraft, the exhaust system also performs thrust reversing function, and also on some other aircraft you can find that afterburning function are incorporated in the exhaust system of a gas turbine engine. In this video, we're going to be looking at these two functions that can be incorporated on the exhaust system of a gas turbine engine. Welcome and enjoy the video. In the last two videos, we have been looking at the parts of a gas turbine engine. In one video, we looked at the intake of a gas turbine engine, and we also looked at the compressor of a gas turbine engine. If you haven't watched the video, there's a link to this video in the description below. In another video, we looked at the combustion chamber of a gas turbine engine, we looked at the turbine of a gas turbine engine, and we also looked at the exhaust of a gas turbine engine. Again, if you haven't watched this video, you can find the link to this video in the description below. In this video, we start by looking at thrust reversing function that can be incorporated in the exhaust system of some gas turbine engine. Thrust reversing is the change in direction of the exhaust gases in order to bring the aircraft to a stop and thus reducing the landing run of an aircraft. On some aircrafts, thrust reversing is done by deflection of the hot stream gases. And on some other aircraft, especially the high bypass aircraft, is achieved by deflecting the cold stream airflow. That is the fan airflow. On turbopropeller aircraft, thrust reversing is achieved by changing the pitch angle of the propeller blades. That is, by changing the blade angle, reversing of the engine power is achieved, and this enables to bring the aircraft to a stop. Ideally, the exhaust gases should be deflected completely forward, but due to design limitations, this is not possible. And as a result, a 45-degree angle is used to deflect the exhaust gas stream forward to achieve thrust reversing. Thrust reversing can only be selected in the flight deck at low engine power settings. There is a lever in the cockpit or in the flight deck that facilitates the selection of the thrust reverser. After thrust reverser is selected in the cockpit, there is an indication provided in the cockpit that enables the crew to monitor the extension of the thrust reversal in the cockpit. There are three types of thrust reversers that can be found on a gas turbine engine. One is clamshell type reverser. Secondly, there is a target type thrust reverser, also called a bucket type thrust reverser. And finally, there is the blocker door type thrust reverser. For the clamshell and the target type, it is the hot air streams that are deflected forward in order to achieve thrust reversing. For the blocker door, we have the fan air that is deflected forward in what is called a cold flow or a cold stream thrust reversing to achieve thrust reversing. For clamshell door, the doors are rotated and covering ducts in which the exhaust gases will be deflected to go forward, and as a result, reducing the speed of the aircraft, hence bringing the aircraft to a stop. As these doors are extended, or as these doors are rotated, they uncover ducts, and these ducts, the uncovered duct is where the exhaust gases, the hot exhaust stream, will be deflected through the ducts to go in a forward direction and thus to assist in bringing the aircraft to a stop. As the doors are rotated, they uncover the duct. As they uncover the duct, they come and block the normal passage that the gases uses in a forward direction or in a normal thrust configuration. They block this passage, and as a result, the hot gases are deflected to the ducts that the doors uncovered when they were extended. or when they are rotated when thrust reverser was selected. So this is the first type of thrust reversing. This type of thrust reversing on most aircraft is actuated pneumatically, but you can find on some aircraft some that are operated hydraulically. The next type of thrust reversing that we're going to look at is called bucket or target type thrust reversal. In this type of thrust reverser, the hot gas streams are deflected forward in order to achieve thrust reversing. These buckets, when extended, they form a bucket type or a bucket shape that deflects the hot gas stream forward. You can see in the normal operating condition of the engine, this bucket, when they are stored, they make up the part of the nozzle area of the exhaust of a gas turbine engine. When they're extended, they make up a bucket shape, and this bucket shape is the one that deflects the gases. When the gas stream comes and hits the bucket, it is deflected upwards and downwards at a 45-degree angle, and thus assisting in bringing the aircraft to a stop. So for the bucket type or the target type thrust reverser, the hot gases are deflected by a bucket type dose that extends at the exhaust part of the gas turbine engine, and when these gases are deflected, thrust reversing is achieved that brings the aircraft to a stop. These bucket type doors are hydraulically actuated of most aircrafts on a gas turbine engine. Finally, we look at a cold stream method of thrust reversing. This type of thrust reversing, it's the cold stream or the fan air that is deflected forward in order to achieve thrust reversing. In this type of thrust reversing method, we have an air motor whose output is converted into a mechanical movement that moves the translating cowl on an engine rearwards, and by moving these translating cowls of an engine, some blocker door extend to block the normal stream of the gases, deflecting the gases forward, bringing the aircraft to a stop. On this system, we have an air motor, we have some flexible drives, we have gearboxes, and we have screw jacks that are incorporated in the exhaust design that facilitates the conversion of the motor output and moves the translating cowl rearward to make an opening where the fan airflow will be deflected in forward direction. Next, we're going to look at the afterburning function that can be incorporated on a gas turbine engine. Afterburning is augmenting of the thrusts of a gas turbine engine to increase or to improve the takeoff, climb performance of an engine, and for military aircraft to improve the combat performance of the engine for a short period of time. Afterburning is achieved by introduction of fuel in the exhaust portion of the engine between the turbine and the nozzle and the exhaust nozzle of a gas turbine engine. This is achieved by burning the unburnt oxygen in the exhaust gases to support combustion. The resultant increase in the temperature of the burnt gases causes an increase in velocity of the gases as they are propelled outwards, and thus causing an increase in the thrust being produced by a gas turbine engine. The nozzle area of the exhaust of an engine that has an afterburner varies depending on the fuel flow of the engine. When the fuel flow is increased, the nozzle area is increased as well. When the fuel flow is reduced, the nozzle area also reduces. Where afterburner is activated or is selected in the flight deck, the fuel flow increases, and as the fuel flow increases, the nozzle area increases, and consequently, when the afterburner is switched off, the fuel flow reduces, and as a result, the nozzle area also reduces. The nozzle ram movement is hydraulically actuated. On some engines, fuel is also used to provide the muscle power to move the ram for the nozzle area extension or for the increase of the nozzle area to the increment and reduction of the nozzle area. Thank you for watching the video till the end. We kindly request you to subscribe to the channel if you haven't subscribed to the channel. If you have any suggestion regarding our tutorials and our videos, you can post it in the comment below. Thank you, and we'll see you in the next video.